Hey everybody, thanks for tuning in. I'm here with Hendrik Hofstadt from Certus One, and he will be explaining the security for validators in a deeper dive. So Hendrik, you can take it away.
Thanks. Hey, I'm Hendrik. I'm the CEO, or more or less also co-CTO of Certus One, and we're a validator company. And for this presentation, just quickly in advance, I'll be mostly answering questions in the end, but Leo, our CTO, will be watching in the chat. And if there's any urgent questions or even want me to stop, just tell him and he will tell me or quickly answer your questions in the chat. So I will pick up essentially where Luke left, but first I'll give you a quick intro. You've already seen Richard earlier this morning, and essentially Certus One started with us free, where I was essentially getting into crypto in 2017, and before just doing a lot of security research, a lot of stuff in cybersecurity, and mostly just breaking other people's systems. So when I started to see the proof of stake ecosystem growing, it was extremely exciting for me to take the other side and actually build extremely secure systems. And that was when I got in touch with Leo again, who I'd met at the European Cybersecurity Challenge, where we've both been hacking and breaking other people's systems, essentially. At this time, Leo has been building systems at scale and working a lot on mitigating denial of service attacks. So this is a topic that I'll be particularly happy to cover as well. And this is when we started to essentially build validator infrastructure. And that was around the very early days of the game of stakes. So how we started to define our validator setup and validator setups in general is we have a kind of usual IT system here. It's a system, and we have a counterparty with which we more or less enter a contract. And this is a service level agreement. And we essentially enter into this service level agreement at the moment that we create a validator on chain, because the chain expects a certain level of service from us. And there's several conditions in this contract specified, namely slashing conditions, which I'll quickly reiterate later. But the very important thing for us is to derive service level objectives from them. And that's the goals that we want to achieve as a validator. For example, an SLA and a condition in this SLA might be online more than 90% of the time within a 30-day time frame. For us, the service level objective might be a little bit more harsh, meaning we maybe don't want to miss 5 signatures in a row, and we determined that to be our expected service level. And there's an extremely good book and associated workbook created by Google, because the people at Google know how to run infrastructure at scale, and we've taken a lot of the learnings that they've written down in this book and apply this to validator infrastructure in general. So let's just quickly take a look at a chain and the conditions in their SLA, namely slashing conditions. Luke has already mentioned a lot of these aspects, and I won't go into too much depth, but we more or less only have uptime slashing and slashing for equivocation, where equivocation is the double signing, so essentially contributing to forking the chain, and uptime slashing for just not participating in consensus, which in return slows down the chain. So potentially transactions are dropped, new blocks are created more slowly, and the other participants in consensus are waiting for us. And we don't want that in a scalable Web3, which is why the chain expects a certain service level from us. And what we derive from that is, on the side of uptime slashing, we define our service level objective to be, we want to submit valid consensus votes for the Byzantine fault-tolerant consensus within the vote time. And in most systems, the vote time is essentially the time that the next block proposer is waiting for, to collect the votes on the last block. And if we don't submit a vote in time, we are essentially rendered as offline in this block because our vote won't be included. So for us, it will be a service level objective to, let's define, not miss submitting the consensus vote within 5 vote times in a row. So essentially being offline for 5 blocks. And for the equivocation, I think the service level objective is quite clear. Never sign conflicting consensus messages for the same height as Luke has described. And from these service level objectives, we essentially derive the properties of our infrastructure. And I want to particularly go in depth in the security aspect of that. And therefore, let me just dive into what high level aspects we have. We have the key security, because as validators, we are identified by a key on chain. And we have the node security, because we have nodes on the network that are signing blocks, that are creating new blocks, and that are essentially partaking in consensus. And we have the human factor and generally processes we built that are extremely important for a validator's security. And this is kind of the structure of my presentation, and we'll start with the key, because the key is essentially what, let me see. Oh, my slides are stuck. Here we go. The key identifies a validator on chain. And Luke has mentioned a lot about Tezos, where essentially we have no split concepts of 2 keys, one for consensus and one for the essentially validator identity on chain, managing the validator account. But on a lot of the newer chains, we have different concepts. For example, on Cosmos and generally Cosmos SDK-based chains, and on Polkadot, for example. Then we have 2 different concepts of keys. First, the account key. The account key is the key I use to register on chain. And I essentially use that to set validator details. For example, my name on chain, my commission schedule, and I can use it to withdraw rewards as well and manage my self bond. At the same time, I use them to assign and potentially even rotate consensus keys. Rotating essentially means taking the currently assigned voting keys and overriding them with a new pair. That way I can essentially exchange keys and reduce the lifetime of a certain key pair. And these consensus keys then are used in the Byzantine fault-tolerant consensus to sign block proposals, so new blocks we create, and consensus votes on other people's blocks. And from that, what we can derive is the validator or account key is a cold key. We rarely have to use it. It's like every, maybe let's say 14 days, we want to withdraw rewards. Maybe we want to change commission. That shouldn't happen too often. So we can keep them in cold storage. The consensus keys, however, need to be online. They need to be accessible by the validator nodes. And Luke has very well described a lot of concepts of how these can be managed. And I want to dig a little bit deeper later. But just for that, it's important that you own these keys and you don't lose them. Because when you lose them, obviously, people can steal your funds. They can slash you, because if they have the consensus keys, they can create conflicting votes. Or they can even delete, unbond, unstake, whatever, your validator. So what that means is you'd go out of business. And if you ever lose control of even one of these keys, which sometimes aren't replaceable, like the account key or sometimes even consensus key, because on Cosmos they can't be replaced, then essentially your validator is compromised forever. You'll essentially have to spin up a new validator right from scratch and convince everyone to redelegate to that one, which from a business perspective, you don't want to happen. And at the same time, if you don't own the keys, if you don't own the nodes, then you don't contribute to centralization. If you just give us as Certus One your keys and say, hey, run the validator for me, we have the keys, we can mess with your validator, and essentially you won't be contributing to decentralization except for your name appearing on chain and like pseudo decentralization. So for storing the account key, we have one very obvious and common way, which is hardware wallets. And we all know and love them. So since we rarely have to use them, we can just go for the usual hardware wallet way. At the same time, we can also go for the traditional paper offline wallets, but please make one thing sure, that you just use the offline keys on a properly air-gapped machine, especially if you have huge amounts of delegations in the future, potentially. These keys are extremely critical because they don't just hold the assets you have in your account, but they are also responsible for essentially the slashable sum of all of your delegations. So it's important that you use a machine that ideally has never been connected to the internet, won't be connected to the internet again, and has no way of communicating and dialing out, meaning removing every piece that can be used for communication or storage, like disks, and potentially even destroying the device afterwards. Coinbase has a really awesome blog post about that. And at the same time, we can use tools like multi-sig wallets. As I think Sonny from Sika just mentioned it, that they've been using a multi-signature account for their validator account. So not one employee of their company or one person from their team can essentially manipulate the chain and mess with it. One key, it needs to be supported by the chain though. And I want to start with like a very basic validator setup and just quickly skip through the first couple of steps because Luke has mentioned a lot of this. Like the most primitive validator is potentially a box running on something like DigitalOcean, or potentially even a hoster like Vultr where they have native denial of service protection. You have the keys on the validator disk. So a single host compromise of this validator will bring you out of business because you could lose your key. At the same time, the validator is connected to the internet. So any compromise of the machine itself would lead to you being compromised. And we want to prevent certain attacks on this. And the first that Luke mentioned was just denial of service. And even with denial of service protection, this usually covers just network and transport protocol layer attacks. And it doesn't catch attacks that happen on the protocol level, like something like a transaction spam to your node. So, which is why people came up with the Sentry architecture, because sentries shield your validator from the internet, but there's one thing that they don't protect you from, and that is direct attacks to the validator, because the validator in this case is still connected to the public internet. And what we can do is we can build an architecture with different kinds of sentries, and this is where it gets a little bit more interesting. Normally, a sentry is connected to the public internet, and essentially all ports of the node are public in the firewall and open in the firewall. So anyone can connect to your node, and your connect can dial out. This is what we call a bidirectional node, because sentry, because it can dial out, it can receive packages. Something that's very interesting, though, that people came up with are outbound-only sentries. And this is something very interesting. What you essentially do, and the cloud provider level, for example, on Google Cloud, you can tell Google to drop any incoming packages and inbound connections. That means no one can really DDoS your node from the outside, because Google will, on the edge, drop all packages, but you can still build up connections from the inside. And having a diverse set of different sentries, bidirectional and outbound, will essentially help you build a more resilient sentry layer. And at the same time, obviously, what Luke also mentioned, a lot of the larger validators are open to private peerings. So using cloud providers' native VPNs or a custom VPN connection to directly dial to other validators with nodes that aren't connected to the internet at all. So in this case, we shield the validators, but the validator is still accessible from the internet. So people could still do denial of service attacks on those. So what you would ideally want to do is do a direct interconnect between those two. A lot of cloud providers offer you direct interconnects to data centers, but this is very expensive, and a software-based virtual private network is in most cases sufficient. The next level of upgrading your validator is the active-passive setup, having the backup validator. But Luke has brought up a very important point about these. Active-passive setups favor availability over consistency. That means what could happen is that you're inconsistent. And inconsistent is what we call equivocation, because two nodes send out conflicting messages to the internet. And that's, in this case, where this node goes down, I say, oh no, this node has gone down. I'll bring up validator number 2. And the exact thing that Luke mentioned happens. Both nodes might come back online at some point, and we'll essentially double sign. And we want to prevent that. So a very interesting way of building a validator architecture is totally getting rid of sentries and centralizing key management, which is what Luke described as the remote signer, essentially. This means that in this setup, you might notice that we don't have sentries anymore, but we have a couple of validators. And one very interesting aspect here is that if we have the key management in a very central place, as described by Luke, with a remote signer where essentially the validator asks the central key management service to sign a vote for a block, the key management service keeps a high watermark of which blocks have been signed before, and then returns the signed vote. There can be multiple validators. Suddenly, we can have highly available configs where multiple validators are running at the same time. And if we can have multiple validators running at the same time, we can get rid of sentries, because also these don't hold the critical key material anymore. So a single host compromise of the validator is nothing we have to be afraid of anymore. We have to be afraid of the compromise of key management service machines, but not of the validators. So one thing to keep in mind, you might be tempted to start auto-scaling sentries in case of denial of service attacks. This is actually something that a lot of people built in the beginning, but once we all started to think a little bit more about it, we noticed obvious mistakes in this concept, because what an attacker now can do is essentially put a little bit of denial of service on all of these nodes and make us spin up a ton of new nodes, essentially costing us a ton of money in the cloud and causing denial of service by making us run out of funds. So it is better to have a diversity of direct peerings, outbound-only nodes, and bidirectional nodes, and rather having a fixed set of them and being able to quickly spin some up, but not automating this. So with this key management service being the essentially central source of truth, we have to think about how to properly build this. We can use a distributed database to keep track of these signatures, because obviously we don't want the KMS to be a single point of failure. We want it to be highly available. And in order to do that, actually, Sunny from Sika and Chorus One have come up with a very interesting concept. And they said, we can use very fast blockchains to essentially keep this high watermark, or essentially register which node is live. So we have node 1 and 2. And what we do is, in case node 1 goes down, node 2 will permanently ping the chain and check whether we are up and signing. And in case a node goes down, it will send a transaction and use a smart contract to essentially make itself and promote itself to the validator. And when the new node comes up, it will check the blockchain and smart contract, and will eventually find out that it's not registered anymore and that it must not sign. So we can essentially get rid of this problem totally in our infrastructure and put it all on chain. This is something I think they're working on Solana with a project called Stronggate, which I'll link when I share the slides. At the same time, there's other solutions to build this remote signer that Luke has mentioned. There's people that have built custom ledger apps. A problem about that is that on the one hand, it's super secure because we have this ledger, the key is never online, and the ledger can store the high watermark of which block we've last signed. But it requires physical presence to recover it, because we need to actually unlock the ledger or replace it. And we can't have two separate hosts with two ledgers because they can't communicate with each other. And if one goes down, if two are online at the same time and they can't communicate, we don't have a consistent system. There's interesting developments being built by the folks at Occlusion, by Zondax, and we're also working on solutions, partially in hardware and partially in software, where we use enclaves like Intel's SGX, ARM's Trust Zone on this fancy little USB stack, which is called a USB Armory, and using technologies like SEV from AMD to store the keys essentially on machines, but within a secure enclave, but running software inside of the secure enclave that is highly available, that can communicate over the network with another instance of the software. So we can make it highly available. Also, there's very interesting attempts of building multi-party computation KMSs by, I think a lot of the research is being done by the people at Polychain Labs under the leadership of Rob Widoff, who are working essentially on splitting the keys to different machines And this is a very primitive version, and it doesn't actually represent how this would look, but you have key shards on different machines, meaning you will have a key shard potentially on AWS, one on GCP, Google Cloud, and one on Azure. And if one of these cloud providers wants to compromise you and essentially attack decentralization, then they won't be able to do anything with their key shard. Multiple of your cloud providers would have to be compromised. And at the same time, each of those nodes can keep its own high watermark, and splitting responsibilities within your team in between these systems, essentially saying maybe person A can just access this, person B this, and person C this. You can essentially get rid of a single point of failure with key storage. So potentially you can combine this with SGX, with SCV and other enclave technologies of storing keys, and create essentially the ultimate solution for validator key storage. And I'm extremely much looking forward on what they're going to be building there. I've linked a couple of key management tools there, also some that Luke mentioned. You can take a look at them later when I share the slides. One thing I also want to mention is there's other ways your validator and your SLOs can essentially be attacked. And that's censorship on-chain, where other people just don't include your votes in their blocks and essentially fake that you're offline, and transactions just being withheld. For example, you trying to migrate to a new key pair and other validators just saying, no, we don't want this transaction to go on chain, and essentially blocking you off. And in order to prevent that, we need very good monitoring. And one thing that's important about monitoring is just monitoring and just alerting on your SLOs, because it is very important that you don't suffer from just alert fatigue. If you're paged every single night, your response time will just become a lot longer. You'll get annoyed and you won't take pages serious. So I'll have a couple of examples very soon, but just collect as many metrics as you can about the system. And Luke had a very great example of tracking things on chain, because that's actually what matters. That is where your SLA is tracked. And so you can later find out what's actually been going wrong, and create tracking tickets in case something goes wrong, so you can follow up and exactly know what to do. So I have a couple of examples here. For example, a disk on a Sentry is full. That can be fixed during working hours on the next morning. So just send yourself an email and it's okay. A redundant validator node in this last setup goes down, can be fixed during working hours. We're still signing on chain, everything's fine. We don't, the data center burns down, and this has actually happened to one of our data centers. It was okay, it was redundant. We could fix it during working hours by just buying new hardware and could watch it burn. But if we don't sign blocks on chain, this requires immediate action. This is where you want to be paged, where you want to have something like PagerDuty set up. And what Luke mentioned with monitoring with Prometheus and Grafana is really very good practice. And setting meaningful alerts is also very important. There's a ton of open source tooling out there. I'll also later have some links for you for how you can monitor different chains and what exactly the SLOs are, and with example alerts. So one important factor I mentioned is the human factor. Because if you have a top-tier validator setup where everything is hardened, automated, the humans interacting with it become the problem. So what you want to do is restrict production access as much as possible, and have infrastructure as code. I think what Luke showed was a very great example. And what you also might want to try is relying less on just cloud provider specific tools, but don't vendor locking yourself, using open source, free and open source software that you can independently run wherever you want. Maybe AWS someday bans crypto. What would we do? At the same time, have good change management processes. I'll dive into that very soon, and document things and have checklists. I'll have an example for that as well. It's what pilots are doing when they are before takeoff. And it's something that's incredibly helpful, especially if you're paged at 3 a.m. in the night and have to get a clear picture of what you need to do. So with production access, I think Luke has shown a great example, but for a very simple setup, just go with a couple of basic principles. Start using universal two-factor and multi-factor auth everywhere. Use a nice thing like this. Use a YubiKey or a similar piece of hardware to secure your accounts and prevent compromise. And also use these hardware tokens for logging into machines using SSH, or using a service like Duo to protect your hosts and have two-factor auth when you log into production machines. And use hardened machines to access production systems. Using your normal developer workstation is extremely dangerous if you're managing a lot of funds. Imagine if you clone a Git repo and there's pull hooks and commit hooks and whatever, people essentially have remote code execution on your machine. If you download a folder somewhere, if you use NPM or something, it's incredibly dangerous. So having something like a Chromebook, which can be acquired very cheaply, is like a great measure to reduce the risk there. And be aware of supply chain risks. For example, GitHub can tamper with your code if you don't pin commit hashes. If you build your node binaries on CircleCI and store them on Docker Hub, where some components until like very recently didn't even have multi-factor auth, they can compromise your validator. At the same time, just checking off lists like ISO certifications won't be sufficient to create a new and secure validator setup. These are made for a lot of process, good on the process side, but when it comes to actual validator setups, this won't bring you further. And at the same time, focus on security by design. Think a lot about things before executing. Just like defining your SLOs, start just building up lists, checklists, and designing your architecture before actually implementing it. Don't just start running a node in a screen, because eventually you want to move on faster and just keep that node running forever and just saying like, okay, it's working right now, I can just keep it like this. You actually want to have like a very secure design right from the beginning, or at least know how you will further iterate and get to the next step. For example, change management checklists. I hope you can read at least a little bit of it. This, for example, is our internal checklist for a upgrade on the Cosmos Hub, because Cosmos Hub upgrades are essentially hard forks where the chain is being reset and restarted from Genesis. And what we have is like a very exact and precise list of steps we have to perform. And at the same time, for these, we assign every single change and attach every single change that we do to our infrastructure as code. So everyone else will be able to understand what exactly was changed and which changes were implemented within this change request and action. And at the same time, then later be able to react to things that have gone wrong, or if you need to roll things back. So there we come to incident response, because sooner or later things will start to go wrong and you want to have someone that's responsible. That means in a small team, as Richard described it before, you'll want to have a clear on-call rotation, even there, and clear escalation process policies. If something goes wrong, maybe start with someone who's in that time zone and who's like, for whom it's working hours, and escalate it to someone else who's responsible, or potentially owner of that chain later. And practice these kind of things. Use testnets. There's a ton of testnets out there. Go there, practice. Just take down systems, make things fail randomly. That's what the big companies do. That's what you should try as well, and have drills and see how you react in this team, and communicate well. Have clear ways of reaching other people. If you can't reach your co-founder, who's apparently got the key to the one production server at this time, you'll be offline for longer than you'd need to. So having these kind of things prepared is very important. And because sometimes shit just happens. For example, in this change request, I think I missed this when creating the slides, we actually also have fields on risk assessment, what can go wrong during this change, and at the same time also a rollback plan. And actually we had to implement this very recently when a Cosmos Hub upgrade actually failed. We had to roll back to the last chain, and in our risk assessment and rollback plan, we specified we'll keep backups of the old chain so we can roll back in case something goes wrong. And this was extremely helpful for us when we actually had to roll back, where people which didn't have processes just were down for a long time until other people just sent them a backup. And in case something goes wrong, write postmortems. just be very honest about what has happened and use these as an opportunity to improve yourself. Write these down. The Google SRE handbook that I linked on one of the first slides is a great example. They have very practical examples of how they handle postmortems internally and how they handle if things go wrong and how to properly write these down in case it does. Because that way you'll be able to specify action points on how to prevent these things from happening in the future and how to potentially even reduce the risk of something similar happening again. For example, this is one of our internal postmortems, which actually happened during this Cosmos Hub upgrade, where just a change request suddenly became an incident. We have, for example, then we have a clear structure for these kind of things. We have context, and this is actually attached to the change request. So we have a lot of context in this case. We have next steps of what we need to do. We have attached action points and tickets, and we have identified the root cause. It's very important to use these kind of processes because that is what will upgrade your validator setup to become better over and over, because you don't need to start with the most secure validator setup. It's important that you plan well and know where the weaknesses are and be honest, just be honest about them and be able to improve them. And that's essentially the end of my main presentation. And I just want to give you the opportunity to just ask questions about anything that's mentioned in there, whether it's about the concrete implementation of something, of Sentry architecture, remote signers, enclave technology, HSMs. I only briefly mentioned them because Luke was going very in depth and already talked about a couple of concerns that people mentioned where HSM vendors were actually broken, like Gemalto recently. These HSMs essentially also, they're just machines, often also just running a Linux kernel and some software. And in order to get these FIPS compliance level, what they have to do is like put a little bit of glue and maybe a temper mesh above it. But there's not that strict thing when it comes to actual implementation of that module. So we think that everything that comes up with all of these new remote signer technologies is going to be much more exciting for us in the long run. Great. You can start writing questions in the chat if you have any. Otherwise, I will also just jump back to a couple of slides and just go a little bit more in depth on things that I quickly jumped through. Oh, yeah, Rick Tobacco. What do you think about churning schemes where validators are sorted by their track record? Yes, I think it depends on how you define just track record. Obviously, validators are just judged by the metrics you have on chain, them being uptime, sometimes speed of production of blocks. There's very different ways how people judge them. I personally think that what we need to take a look at is just how validators communicate. And I think there's a couple of cool projects online that try to rate validators, but it's very hard to judge them. I think it's very important to take a look at how validators handle incidents, and just taking the pure on-chain track record sometimes doesn't really give a clear picture of how good this validator setup actually is. For example, during the game of stakes, and Luke also briefly mentioned a part of this, a lot of people were optimizing their setups to be more available than consistent, because on the game of stakes, one of the main metrics was how many blocks have you signed. So people who were running just a DigitalOcean node very close to the rest of the nodes. So often we see clusters of nodes forming. For example, if you have a node in Singapore, but on this particular network, most validators live in some US AWS region, you will have a hard time getting your votes included in a block. And on Game of Stakes, what we saw was that people that had very sophisticated, maybe even multi-layer Sentry architectures were missing a lot of blocks, because obviously it takes some time to traverse this Sentry architecture and it increases latency. While someone who was sitting in the US we're very close to the other validators with just a DigitalOcean node without any sentries, just had essentially one hop to the other nodes to transmit the vote and had better uptime in the end. So taking these like raw technical metrics, I think is not the best way to judge validators. I think what we should do is delegators should essentially take these as like a first metric, but then research a little bit more or use a great online, there's some sites that just review validators, interview them. You'll quickly realize which of those are serious and which are maybe bought. But it's important to take a look at how people handle these incidents. For example, the Occlusion folks with Zaki and Tony, they've done an incredible job at just writing postmortems and also publicly making them available. And I think this is really amazing because it shows how they even take minor mistakes where they just drop 3 blocks and write a very, very, very comprehensive document about it, explain to you, and also validators and new validators take this as a resource for your learnings. Validators publish their postmortems oftentimes, learn from those, because what they did was, even with this minor mistake, which others would have just like hidden and told no one about, they went public and said, we have improved. We've taken this bug and we have fixed it. And we've implemented this and that measure so this never happens again. And I would use these kind of things when clearly taking a look at validators and judging them, because that's what makes the difference between a top tier validator and essentially one that isn't top tier. Let me see. What else do we have? Oh yeah, what Leo just mentioned is the kb.certus.1. In the very early days of the Game of Stakes, we've written a knowledge base, which includes a lot of very hands-on examples of how to better implement validator infrastructure. It goes through all of the things that were essentially mentioned in both Luke's and my presentation of, from pets to cattle, and why you might want to use or might not want to use something like Kubernetes, what remote signing is, how Sentry architectures work, why we maybe won't need them anymore in the future, how to protect keys, how to monitor, and also something that I would now go a little bit into that is, in my opinion, also a part of security, is just business continuity. Being able to also secure your validator, not just on the technical layer, but also from a legal perspective. I'm not sure. I think there's also going to be a presentation about this. But one thing that also differentiates the big fish on the chain that catch all of these large fund contracts from smaller validators is that those have contracts, specific contracts for delegations that they can sign, which specifies exactly the SLA, not just with the chain, but also with single delegators. So a fund could have a contract with a large validator like us that gives them certain securities and assures them that we will perform our service well. This is something you should also consider. There's some interesting templates online. I wouldn't say templates, it's contracts of other validators. I think Figment has made their delegation agreement public. I think you can check it out on their website and just take a look as a guideline of what other people are offering. Because if you want to start a validator business, it's important that you also need to convince a certain audience. When you start your business, you might be able to build a very good setup. For example, I've just been talking to someone who has built a very new remote signer tool for Cosmos. They've been building it as proprietary software, not making it open source. But essentially, they now have one of the top tier technical validators on Cosmos, but they are ranked somewhere around rank 110 or 120. And that's not because their tech is bad. It is because they just weren't able to secure delegations. So while you need to focus a lot on the technical aspects, it's also very important that you think about the aspects of how can I be different from others? And commission rate isn't certainly the only aspect. It can also be using that money that you earn for a good purpose, as for example, the CK validator that's investing in zero knowledge proof research, or maybe contributing to the community in one or the other ways. There's a ton of opportunities how you can get yourself some visibility in the community. And I think start up with a basic validator setup, try to implement as many best practices as possible right from the beginning, starting specifically from key management, and iterate from there. But don't forget the other side, the business perspective. I think this is extremely important. And talking about that, I want to get back to one specific point on the Kubernetes side. And that was what Luke just very briefly mentioned. It was that he says that specifically running validators on Kubernetes might be something that could easily lead to downtime or not be as stable. We actually also write that in our knowledge base. We say validators are pets and not cattle. But I think that with all of the developments of the remote signers, here we can see that validators are actually mostly cattle. And what I would like to dig into now is how can this actually be possible? And one thing how this can be possible is that we actually either get rid of a lot of state in the validator, and new projects are doing a great job. For example, if you look at Solana, which maybe is not the best example of scaling fast because the Solana setup involves some other very hardware intensive tasks, but they have a snapshot mechanism, and Cosmos in the Cosmos SDK is implementing something as well, where you have a quick sync mechanism, essentially, very similar to what you have on the Ethereum chain. And this will allow you to bring up new nodes without having to have a 60 gigabytes backup. Also, the Tendermint team has been working on just pruning a lot of the state, meaning while you now have a 80 gigabyte block store, you might only need the last 2 blocks or last 4 blocks in order to spin up a validator. And they're working on new tools and fixes in their software and improvements in their software that will make it easy for you to spin up new nodes without having to handle backup restoration, etc., manually. So this is something that could be very exciting for you when designing these kind of infrastructures, because there's a ton of improvements on the protocol side. And I'd really encourage a lot of you that when building up your validator infrastructure, think about things that might just be broken in the validator software. Don't just take these things as unchangeable and immutable, because these chains, especially proof of stake chains, have something that's very unique, and that's oftentimes extremely well functioning governance, and they can innovate very fast. And with that innovation, you will be able to bring in your changes extremely fast. So if you have something that's blocking you, there are good chances that you might be able to change something in the chain software itself and have it propagate up to the chain actually, and make your validator setup more secure. Okay, I think there are a couple of questions. Okay, what are my thoughts on Solana's 100% slashing? So I think Solana had some very interesting ideas for how to change how slashing is done at the moment. Currently, inconsistency is immediately punished. One interesting note, however, is that depending on how the consensus mechanism is implemented, you might not be slashed immediately, or you might not be slashed at all, even if you have 2 nodes running, because they might actually sign the same blocks. At least that's the case in Tendermint. You might actually double sign, but not be slashed for it because you don't sign 2 conflicting blocks. What Solana has been thinking about with in conjunction to the 100% slashing is making slashing dependent on how far back in the chain you go. That was one idea that they proposed, which I honestly haven't thought a lot about, but what they essentially were thinking about was making the amount that's being slashed dependent on how far back you go, where you essentially fork the chain. So if I immediately fork right now because 2 nodes are running at the same time and signing 2 conflicting things permanently at right now time, that might be handled differently than when I go back in time and just fork the chain at a random point. And their proof of hash mechanisms, which is essentially a cryptographically mostly secure wall clock, might help with that. So what they say is essentially they're trying to find ways of how to not slash involuntary equivocation. And I think when you equivocate voluntarily and maliciously, you should be punished for it. And 100% slashing, while it sounds harsh, if only triggered in a case where you are 100% responsible for it, is fair, I think. Why we're not a Tezos baker? Actually, that kind of brings me back to the point of the business aspect of validation. We were in the we joined Cosmos in the very early days, and we joined a couple of other networks that we validate on in the very early days. And talking about your validator businesses, potentially, it is super helpful to be there from day one, because both unfortunately and obviously fortunately for us, the votes are very static mostly. If you are able to secure a large amount of delegations in the beginning, and I think that's also very, very interesting for the point that Eddie brought up with sorting by voting power, it will give you more visibility. And you will also be known in the community and eventually also by the investors that are large stakeholders in these protocols. So for us, we were essentially late to the game for Tezos, which is why, from a business perspective, while we might have been able to build a good setup, we essentially thought that from a business perspective, we probably wouldn't be able to change the status quo much and work our way up, especially because some of the top validators there already have like top tier setups that are extremely hard to beat. Or if you just beat them by a little, their reputation, just because of them having validated for such a long time, is so much greater than ours could be in their community. So this is why we decided to not join the network. And I think right now is an extremely good time to get into a lot of networks. There's so many networks having staking competitions right now that allow you to acquire stake, that allow you to just show presence, to contribute and be seen by the large stakeholders. And this is a essentially once in a lifetime opportunity for you to get on. And obviously on Tezos, we also had the self-bond requirement. And I don't want to dig too deep into that, but we, as no venture, like not being venture funded and being fully bootstrapped, just didn't have the initial capital to bring up for the self-bond. While on the other networks, we could acquire those via the staking competitions, essentially. And what we didn't want to get into is just lending and investors Tezos and putting them up as self-bond, because we thought it was too complicated from a legal perspective. Which is the latest network we joined and why? Oh, let me see. How would you implement a time to recovery metric? How do you track an outage in the chain? Yes. How to track an outage in the chain? It's quite simple. Luckily, the chain is immutable, and it gives us a essentially perfect view on the history of what has been happening. So what we can do is we can take at the blocks in a proof of stake and Byzantine fault tolerant chain, and we can essentially check whether our validator's public key has signed a vote, and one vote is in the block header. So if we see, we essentially have to scan the chain, and we're actually doing that as well. There's open source tooling for Tendermint on our GitHub, and a ton of other validators have also put out extremely amazing tooling for these kind of things that essentially use the API of the chain to scan block by block and verify that you were actually included or not included. And what we then do is essentially export these metrics to Prometheus, visualize them using Grafana, and then use Prometheus queries to alert to PagerDuty. So for example, if we miss more than 5 or 10 blocks in a row, I don't know the exact metric we put out in the moment, we are paged, and this is essentially counted as uptime. At the same time, you can take the chain and you can scan every block and just count how many votes validators have put in and track their signing performance. But these can be manipulated by censorship attacks, as I described them before. Someone else proposing the next block could just omit your consensus vote. Velocity. Oh yeah, Velocity is a good example. Velocity was one validator that was not waiting for other validator votes to come in, not waiting the, I think, 5 seconds on Cosmos that you usually wait, but they were just putting out a block as soon as they saw 2/3 plus of the votes, which is required for a valid block in the Tendermint consensus and BFT consensus, and then essentially proposed this block. So they were essentially censoring a lot of people and not including their votes, which means they appeared offline. They also received less rewards on the chain, but at the same time, they weren't really down, which is alert fatigue. Just try to find reasonable amounts that you want to alert yourself for. Because if someone censors you and you're paged in the middle of the night, that's nothing you want to happen. That actually happened to us. We've been making this mistake, and we've actually learned a lot from it. During Game of Stakes, we were paging us for every single block miss, essentially every single vote miss on the Cosmos Game of Stakes chain. And this sometimes woke us up 3 or 4 times in the night. And believe me, at the 4th time, you won't be that awake and you won't be that willing to react. So set reasonable metrics for these kind of things for alerts, because this is extremely important if you actually want to react fast. Our biggest learn, it was that processes can save you. I personally was in the beginning a bit skeptical about Leo writing such huge checklists and having processes for every single thing that exists, but or every potential case that could happen. But actually, when these things happened, like with the Cosmos Hub 3 rollback, I was super glad to have these kind of processes in place. So essentially, the biggest learn is the things that Google writes in the Site Reliability and Engineering Handbook is essentially really the truth. They don't just overstate these things. It's important to have good processes. Even with a more simple validator setup that's not highly available, especially there, these processes are extremely important, because if there's no more question, let me just give you one interesting insight. Even if you, I think my camera's a little bit blurry. Even if you have just a single validator running, there's a chance of you double signing, because this node is keeping track of which blocks you essentially last signed. There's a file on disk. It's mostly f-synced to disk, meaning the node makes sure that every time it signs, the file is actually written. But in case of some strange failure in the OS or your drive layer or whatever, some RAID setup being broken and disks failing over and your node failing, it might come up and see an old version of this log file, and you might actually double sign, which is why even a single node setup has some not negligible risk of double signing. So this is why we're particularly excited about all of the remote signer work that's being done. We ourselves are also working on a open source remote signer software utilizing some of the latest trusted computing technology. So you can both store your keys online and securely run these validation pieces for a couple of chains from a single instance. And we're extremely excited to see the work that's coming out of Polychain Labs, because what's really important in this community is working together. There's a ton of resources being published, and if you build a tool, open source it. It's so helpful for the whole chain, and essentially having these kind of things in like a highly available setup in the later stages of a network isn't that important anymore. In the beginning, it might give you an edge, but helping the whole chain and the whole ecosystem grow is much more important, because even if you just have like a medium-sized stake, if the chain grows and is secure, all validators, you all working together, keep the chain alive, then your revenues will also grow, because the value of the underlying asset is increasing massively. And I think there was just one more question on which network we recently joined. It was actually Solana, and that was the very latest network we joined, which has also very unique aspects. That also means you can streamline a lot of your different validator setups. As it was mentioned, these are economies of scale. If you have one validator setup, a lot of the components for the others are going to stay the same. And automating as much as possible will both prevent human failure. If you just run your validator in the screen on a DigitalOcean box, the rate, like the chances of you doing something wrong and breaking it is much higher than having it automated with Ansible, having a Kubernetes cluster running, and having your infrastructure very well defined as code. Because with these remote signers, validators are more and more becoming cattle rather than pets, because what is going to be your pet eventually is just the key management service or remote signer, but not just the node. Okay, amazing. One other thing is that obviously when starting with the chain, let me just quickly get back to that process, because that is one of the most important things from just my perspective. When you enter a new chain, look at the SLA you enter into, derive SLOs, see how many components you can essentially steal from your other networks or that are already open source. Take them and plan out your new infrastructure and go ahead and build your new validator setup, derive from that design, maybe even build like 3 different versions of it in your design. Like one, this is like our beta stage validator. This is our staging state, like let's say alpha, beta, and production validator, and iterate on these and find reasonable steps at which you want to proceed. Because on chains like Terra, while everything on the validation side is exactly the same as with Cosmos, there's one more condition in the SLA, and that's running an oracle, actually. You need to fetch prices from the internet. You need to have another hotkey. You need to essentially submit these prices in time, or otherwise you could be slashed as well. You need to know these things. A lot of validators just missed out on them. Stay in tune and look at the updates on these chains, so you can essentially all of the time have the most secure validator setup that's possible for you to implement. And this is extremely important because a lot of concepts are always the same. With the Oracle, the only critical part is, again, uptime and key security. And if you have a proper key management system, you can reuse a lot of that in the later setup. So make use of these common ground between the chains, and you'll be able to move extremely fast. And you don't have to start with 5,000 dedicated servers in a cage. Start with a simple validator, but from the beginning on, have good processes in place. That's essentially the most important message that I can give you, and my most important learning. And I think we're also almost out of time.
Yeah, that's about all the time we have. But Hendrik, that was incredible. I couldn't even write down all of those insights as fast as you were saying them. So I'm taking notes as during these presentations. So I will write up all of these things and
that's amazing.
Share some of them. So this is
one
really,
thing
really cool.
I can say that is take a look at the knowledge base. It's open source. You can also contribute to it all of the time if there's things I've said that aren't in there already. And if we all collaborate, we will all have better validator setups in the end. Yeah.
Oh, I love that attitude. So thank you so much again. We're moving on to the next panel.
See you. It was a pleasure.
Again, yeah, thank you. Thank you. Stay in touch.
Thanks, everyone.
Bye.
Almost right now.
So session's ended.
Okay.